Hello everyone, Spirit here. Guys, let's welcome. Voila. Sony. Sony is plugged in. It should be having power. I know that viewers are mainly focused on the electronics. Like if you would check my post, game consoles, laptops, and I think TVs as well. But this time we get something else. This time we got a Bluetooth speaker soundbar. Okay, I'll open it because I've checked the fuse and the fuse is okay. So I did check the fuse. So let me open it and be right back. Guys, when I'm doing it, I hear that it's a new, I mean it was never open, so hear the sound. Okay, you've heard the plastic? Hear me. The same sound. I don't know if you can hear it, so I'll do it one more time. Oh, that's the sound of the electronics which never been opened from the manufacturer, because it gives this sound, so you can recognize it, yes? And that's worth to know, because if somebody says, oh, this device was never opened, when you don't hear the sound, that means somebody was inside already, okay? I'll be right back, I'll finish it off. Okay guys, so I removed the cable and I will check the cable as well, just in case, because you never know what's wrong, yeah? So let's get the blue one. Okay, let's get the brown one. Good, okay, so we know that the cable is fine. So we can either connect the cable and start measuring here, or we can just literally take out this board and start measuring out of the board, which I would recommend to myself, actually, to be true. I prefer to take this board out. You know what, I'll pause it, I'll take it out, and once power supply is out, then we can start to measure it. Okay, so I've got this board out, and we should have standby voltage, okay? We should have something like standby voltage, which we don't. We don't see that capacitors are blown. After doing visual inspection, we don't see anything bad here. So what we could do is we know that on these two pins, when we will touch the meter, it won't be beep, yes? Why do we know? Because this would blown if we have a fuse okay, but we know that fuse is okay, so it shouldn't be beeping. Exactly. You see? So it's fine. It's completely fine. Now, that's our transformer and that's our output. So you can say that the hot side is here till the transformer, then when there's opto-isolator, and the transformer, that's a cold side. Okay? So now the question is, yes, do we have a short on this side or on this side, or we've got something just broken and it's not even a short? So let's see, there are diodes here. So we got an anode on the left, so let's do like this. You don't see, maybe now you will see. Okay, so anode, now we should have some reading on the meter, and we do. Now the opposite way, we shouldn't have the reading, which is good. Okay, and the second one is the same way. So anode, the red probe on anode. This one is good as well. And then, good. So why I was checking it? Because if there would be short, the opposite way, what would happen, yes, would be passing through from cathode to anode as well. Which I knew it won't be. I was just wanting to double check. Okay, so here is okay from anode to cathode on this diode, and on this. Ooh, okay, it was for a second. No, nothing here. Now it is 455 now. Okay, so we don't have short, that's good. So we shouldn't have short on the transformer. Okay, why do we have AC and DC? That's a bridge rectifier. Okay, good charging and discharging. Okay, I'll show you how to check bridge rectifier. I'll just pull one on the screen. Okay, so I found it on the CDN1 by yjus.com. Doesn't matter. I can show you the website here, okay? So that you'll know which website I took it from. Yes, to byjus.com. Yes, so I took it off this website. But anyways, long story short, so we've got an AC coming in, yes, and you got A, B. So where the AC comes in, we know that if we touch from point A to point B, that's the direction of the diode, and we shouldn't have to B because this is anode to cathode, which is the proper way. But here is from cathode to anode. So from A to B, from AC to AC, we shouldn't have anything because here we're going from cathode to anode. So this is the opposite. So when we touch from the AC, from AC to AC points, it shouldn't be anything. Yes, and then this way as well. So whatever way we are checking, we shouldn't have a short. Okay, so let's check. The AC are the inner ones. And we don't, which is good. That means we don't have a short. Let's change probes, and it shouldn't be anything as well. Okay, brilliant. So we know that the AC side is okay. Now let's continue with the picture. The last thing which we can do is points C and points D. Now points C and D are the DC output from it, yes, and then when we look from point C, anode to cathode, anode to cathode. So if we check from C to D, we should have a reading, yes, because it's going through two diodes. Whereas if we are checking from the D to C, we get a cathode and anode. So in one way, it should work okay. In second, it shouldn't. Hopefully that makes sense. So if we do, let's say, we apply red probe on the minus, you see, nothing. The opposite way, now the red probe is on the plus and the minus, and it's not. So it's charging, discharging, I'd say. Yeah. Okay, so it's minus, and minus has 436. Now it's nothing. So it's looking okay. Now this is charging as well. So we don't have a problem as a short. That's not a short problem. That's just missing current somewhere here. Now the question is where we're missing current, okay? Because that's the question. So what we can do is we can apply the current, and we expect to have current. Like, don't do it at home, okay? If you don't know what you're doing, or if you haven't been trained, you're doing it at your own risk, and that can kill you, because here I'll be using 246 volts, guys. So it's not something. Yeah, nothing has blown. Very good. Okay. So now we expect to see here. Maybe that will be better for you to see. I don't mind. Only entangled, so let's untangle. Okay, now get it. Great, awesome. So let's see. On the inner ones, we should have 246 or something. So these are here, so we can test it for here. And that's 247. Yes, so that's okay, that's good. Now we change to the DC 1000, and we should see on this one here, it's one probe, and then here's a second. 340, the opposite way, yeah? So that's a plus, that's a minus. 340, now it's a plus. Now this plus, it's going through some coil. Okay, so I want to stabilize the flow of the current. So let's check the O. Okay, it's 340, very good. And before it, it's 340. Okay, so it's coil works like a buffer. Yes, so you load it, and then it's just receiving proper dose and then release, small release, once it's charged, of course. Then we get this big cap, so the big cap should have a current. So here and here, and we see that it's 339, so it comes to this. And in that case, now we reach the transformer. The transformer, which will have 340, exactly. So out of the transformer we get again AC. Ooh. And we've got nothing. Nada. Nada. So if we've got nothing, that's 7 volt. But here we should have more. And that's why we've got no power on this. The transformer has burned, but burned in the way that it didn't damage anything. This transformer is dead, unfortunately. Yes. Or the current, yes, there's another option, because it can give us a standby voltage, which is this, and then through opto-isolator come back and give the signal impulse to get the proper voltage. Yes, because we've seen opto-isolator, so it's not always on. It's on when we press the standby button, yes, the power on button, and then when you press it, the signal is sent from the main board here through that opto-isolator to tell the transformer to switch this MOSFET-y thingy, and then that MOSFET-y thingy will switch on the transformer, and then we've got charged those big capacitors, and then we get power. So because we don't see any short, that can still mean that it's not a problem with the transformer, but it's maybe the MOSFET burned. Okay, so that is still a chance. So we can't take for granted that, oh, transformer failed. No. It's on this side. Okay, so I need to be really careful because I can even kill myself. I need to pause. Hold on a sec, guys. Let's put Robert's. That's my friend, so he won't mind that I've said his name. I could say my best friend, but we don't see each other too often nowadays, so I don't know if he would feel worse or better if I will say my best friend, so I will just say friend. Okay, I'm curious what came. And then we can check if that MOSFET is faulty or no, different credentials. That's recycled packaging, that's a good thing. I like that somebody used packaging which was used before. That's a good thing actually. I don't want to show those details. Take it apart. Okay. I don't reuse nowadays packaging, so. Oh, okay. Yeah, I switched that one off if you would wonder. Oh, that's the main board for customers' TV, I'd say. Okay, good. Can stay open. Can stay just outside. Is it for this one? Samsung, could be. Could be. Free HDMI, LAN. Yeah, fits. Okay, well, let's put it aside. And we will have a board replacement in one of the videos, and we will see if that will solve the problem. We can go back to this fella here. Okay, so let's remember that's the cold side, I can touch it. And here we get 3 pins. So do we know what the chipset is? Because it's in the viscous something like that. We need to check what the chip is. So when we know it, I can put you on the screen and we won't have to guess it. But first I need to open it. So I'll remove it, I'll find it, I'll post it on the datasheet of that chip, or MOSFET probably, that will be MOSFET. And then you will see how we should measure it. Okay, so this has 5 pins or 6 pins. So this might be some voltage regulator, not only the MOSFET, yes? I've unscrewed it, but I can't see it. I need to spend more time to find it out. Okay guys, so this is quite advanced stuff actually, and this is a circuit which is integrated circuit properly, you know, like on a better scale. So what we can do here is we can zoom that in. Now, when AC is coming, we've got a bridge rectifier, yes, our bridge rectifier. And then through Zener diode and diode, we go here, okay? So it's like a drain source collector, yes? Like a transistor, yes, in my opinion, okay? So we've got 1, 2, 3, 4, 5, 6 legs, and which is correct, yes, which is correct. And it's switching. So you see it's a enhanced EcoSmart integrated offline switcher with advanced features set and extended power range, okay? So from drain to this source we should have, yes, we should have pass through. The opposite way we shouldn't. The question only is, you know, how to read it, because we don't know which pin is what. So that's my problem, yes. And I can't. That's what's inside happening. But I still. Oh, see, you've got even written here. That's a source. That's what I was talking about. I didn't know. I didn't open that, you know, in the past. Drain, C is stands for control. I didn't know that. Frequency here is F, yes, so voltage monitor. So it's monitoring voltage, and then based on that it can control. See, it has internal supply, and it can switch on the power when it receives that impulse. Okay, special frequency probably is. So yeah, that's it. So we should have that here, and I would say that it's most likely this what fails and not transformer, because transformer is not shorted. So, you know, it would be blaming just because we don't understand things, yes. For me this one failed, and that's why we got no standby. The only thing that I need to confirm it, I need to find pin output on one of those data sheets, and then compare it with this. That's packaging. That packaging was written here. That is 252 packaging. The second is 262, so then that will be one of those packaging. I know, yeah, top 252, 262. Those are the types of packaging. But what I want to say is I need to order it because I don't have it, and I need to check if eBay has it, and then I'll record part 2. I'll need to test as well before I'll order pin output, okay? Because if I'm not sure, then it's a problem. What else I can see here? I can't see anything else here. We see that transformer receives a power, okay, but the power is only 7 volts sent. And then when 7 volts is sent, because we see that 7 volts, that goes and should come back when you press the power button. If this doesn't come back, then either is this or there is a fault on the main board. So I will check the pin output, test this one, check if the voltage, you know, comes out on those pins here on the output, yes, section, and I'll make those tests, and then when I'm ready I'll record second episode to not waste too much time right now. Yes, to save up time on the recording. So that's it in the part 1, and I'm quite curious if there is a fault on the main board, maybe chipset which manage this standby is not working, but it does receive a standby voltage, or there is a problem with this one, and that's why, you know, it doesn't even allow us to press the power button. Yes, so I don't know that. Yes, for me it's 50-50. I'm guessing things, so I don't like guessing. I know that we should have standby voltage, okay, and standby voltage is coming to this, and then there is one more here, okay, which drives it. That's why I need to do the research. If that 7 volts comes to this, and then should come to those pins. Yes, so I don't want to confuse myself. I need to check pin output, I need to check that second chip, which is probably the MOSFET as well. I don't know what the model is. I don't see. Let's check it before switching off the recording. Okay guys, so I found, I'll show you. I found we've got this packaging here, okay, and I've checked, so we get it properly. On this side is written, we should have a connection from the drain to the source, which is fine. From source to the drain there shouldn't be any, and it's fine. But I get a problem when I'm checking from collector, yes, that's fine, to the to the source I should have, whereas from source to the collector I shouldn't have, okay? So that's, and I've got 1900 something, so let's check that's connection from source to collector. So from 5 to 3, yes, from 5 to 3 we shouldn't have any. Or I don't remember something, but I'd say from 5 to 3 or from 3 to 5. It's okay, collector is on 3 and source is on 5. So from source to collector, from 5 to 3 we shouldn't have any. So 5 is this, 3 will be here. So from 5, that's this one, to 3 to this one. Oh, am I wrong? Yes, from 5, which is source, to 3, which is collector, we shouldn't have 490. Okay, it shouldn't be there. And it is. And then the opposite way, so we do red probe on the pin number 3, and black probe on 5. So we still got 1982, and that's red probe on pin number 3, which is a collector, and a collector to to source still shouldn't have. Well, that should have, yes. So either I'm, you know, mixing something up, That's why I need to check, I need to check it out myself. I've checked as well the other one, which is here. I'll show you. But this reading is fine. So when we test from 2 to 1 and to 3, it shouldn't be anything. And then from 1 and from 3 to 2, we should have proper diode reading. Okay, so we can take this one the other way around, and that's this one. So from 2 to 1, look, oh, it is. So from 2 to 1, but it's charging, yes, it's charging capacitor. And then when I'll take the probe on 2, so will be from 1 and from 3, look. Okay, so it is charging as well, but up to 200 only, which is okay, because that's a quick diode inside. Okay, 204, but this way it shouldn't be, you see? So that's the question. I'll spend more time, I'll record part 2, and we will know, but I don't want to make it too long video, yes? So I need to check why there's no standby voltage, yes? Is it me wrongly diagnosing this component, or is it a problem with this diode or something else? We will know in part 2, but that's it in this episode, guys. Thank you for watching. If possible, please do like or subscribe. I'm reminding myself all those things. I was fixing them in the 90s, like this meter. That's when I was doing it, and now I don't do. Plus it's a new components all the time I'm seeing, and I need to learn those new components as well. So unfortunately I need to learn, yes, and then I can do it much more efficiently. But for now, this new component is a mystery for me. I need to learn it. So thank you for watching. If you did like or subscribe, here's likes to you. Thank you for watching. If possible, let's fix them all, and see you in the next video. Bye.